We just saw how to quantify samples of different elements using conversion factors. But sometimes, when we have a series of samples, we just want to know which one has the greater mass, or which one has more atoms. In most cases, we should be able to do this without a calculator, simply by estimation. We can continue to use our knowledge of molar mass and Avogadro's number. However, we will use round numbers to rank the amounts of elements by estimation. The key is to compare a sample we are given with 1 mole of the element. Is our sample 1 mole? Greater than a mole or less than a mole? If so, how much greater or how much less? This will allow us to estimate the mass or number of atoms in that sample. Comparing multiple samples allows us to rank them. Our first example asks us which has the greater mass, 1 mole of carbon or 0.5 moles of sulfur. Since we already know the moles of each sample, we can estimate the mass of each sample. The periodic table tells us the molar mass of carbon is 12 grams per mole. Yes, the table actually says 12.01, but since we're estimating without a calculator, we'll round that to 12. So our sample has a mass of 12 grams. The molar mass of sulfur is 32 grams per mole. This sample, being half a mole, must have a mass half of 32, or 16 grams. We can see the sulfur sample has the greater mass. We always relate our samples to 1 mole of material. Here is a second example. Which has the greater mass? 4 times 10 to the 23rd carbon atoms, or 2 times 10 to the 23rd sulfur atoms? The molar mass of carbon is 12. But first we need to know how many moles are in our sample. Notice that 4 times 10 to the 23rd is 2/3 of Avogadro's number. So this sample is 2/3 of a mole, or 2/3 of 12 grams, which is 8 grams. For sulfur, the molar mass is 32. Notice that 2 times 10 to the 23rd is 1/3 of Avogadro's number, or 1/3 of a mole. We estimate 1/3 of 32 to be between 10 and 11 grams. We see that the sulfur sample has the greater mass. Even though there are twice as many carbon atoms, since a sulfur atom is more than twice as heavy as a carbon atom, the sulfur sample has a greater mass. Our third example asks us to rank 2 samples in number of atoms. Which contains more atoms, 12 grams of carbon or 30 grams of iron? This question brings us back full circle to where we started. Recall that we had 2 beakers with black solids. The beaker containing carbon had a greater volume of solid but a smaller mass. We had asked how could we tell which has more individual items or more atoms. Now we know how to answer that question. Carbon again has a molar mass of 12, so this sample is 1 mole, or 6 times 10 to the 23rd atoms. Yes, Avogadro's number is 6.02 times 10 to the 23rd, but we're estimating, so we drop the 0.02. Iron has a molar mass of 55.85 grams per mole, which we can round up to 56. Our 30-gram sample is roughly 1/2 of a mole. So the iron sample contains about 3 times 10 to the 23rd atoms. Our rough estimations show there are more atoms in the carbon sample. You should notice that I didn't need to do the last step, multiplying the moles by Avogadro's number. The carbon sample had more moles of atoms, so it had more atoms. It's like if there were 1 bowl with a dozen eggs in it and another bowl with half a dozen eggs, I don't need to figure out that the first has 12 eggs and the second has 6. I already know the bowl with a dozen has more. In summary, to rank samples, we ask how many moles are in each sample. Finding the moles is the key. Once we have that, we can use molar mass or Avogadro's number to estimate the mass or number of atoms. This is a skill that takes a little bit of practice, but being able to estimate masses or number of atoms comes in very handy, especially when checking your work and other problems. It also really lets you know that you understand the mole and how to quantify elements.